As we work on this practice page, it's super important that you're using your notes from the other side. I know sometimes we get in a habit of just only having one page up at a time, but when we keep our pages flat and open, so we'll be looking at pages 24 and 25, the answers for this are right where they need to be on the other side. The other super helpful thing for you is going to be having that periodic table folded out or looking up at the periodic table on the wall. When we do our tests, when we do our quizzes, you're going to have a periodic table. You just need to know when, how, and what to use it for. So, this first section has our definitions. So, that should be really easy if we are looking at the other side. Cation versus anion. So, we've got a couple different definitions there. So, make sure that you're reading carefully. These are the exact types of questions you can expect on the multiple choice part of our test. And sometimes they're tricky if we rush through them too fast. Bohr models. One thing that's going to be the same with these Bohr models and the ones that we did earlier are that the protons for beryllium, oxygen, nitrogen, and aluminum are the exact same no matter what else changes. So they're not the same as each other. Sorry if that was confusing. They are the same as every other atom or ion of beryllium. So we find beryllium and on the periodic table and we know it's protons, whether it's an atom or an ion. Same thing for oxygen, same thing for nitrogen and for aluminum. To get the neutrons, just like in the last video, we take mass, that 9, or for oxygen, the 15. We don't use the number on the bottom of the periodic table. Don't worry if it's different. Don't worry if it's the same. Don't worry if it's close or far away. This is the mass of the atom and the ion we're looking at. Two of these will form cations or will have outer rings that are very close to empty. So they're going to lose electrons to become positively charged cations. So their outermost ring from their atom will become empty. Two of these will become anions. Their outermost ring from the atom is almost full, so we will fill that up, or we will gain enough to get that ring to have 8 as it becomes an ion. Remember to put the charge up on this line as well so we can see what ion it forms. You can check that by looking at the charges across the top of the periodic table. The periodic table on the side wall will tell you how many valence electrons something has. And the periodic table that we use, the one in your notebook, will tell you the charge after it becomes an ion. This chart down here is a lot like the subatomic particle concept builder, where we need to write a mass number, an atomic number, and a symbol. And then for all of these, they will have a charge. So you'll have a number right here, right here, right here, right here that matches the charges. So make sure you don't miss any of those. The top number matches our mass number. The bottom number matches our atomic number. And we remember whether it's an atom or an ion, atomic equals protons. That is always, always, always true. The electrons are the things that change. So we can know the electrons based upon the charge, or we can know the charge based upon the electrons. Remember, for neutrons, we get that by looking at mass and protons. 19 minus 9 told me I had 10 neutrons. So I can do this minus this, and that's how I'll fill in my neutrons for each of these columns. We've done all of these things before, and they're all everything up here is directly out of your notes. So make sure you not just fill that in, but you understand and think about it. And if you get stuck, don't just go to the PowerPoint, go to the video to get that little bit of extra explanation.